increasing the computational resources with his alia ranks.
But what happened?
What happened?
Yeah, what happened, Marta?
Well, I feel kind of guilty because since we have TALP installed in Mare Nostrum 5, it's very easy to find out your parallel efficiency. This is the TALP output, and here we see that they have a very bad communication efficiency. So if they find this, they kill your jobs and you too.
So what? How do I know the resources I have to use? I run plenty of simulation during the day with different requirements, different meshes, different physics. How do I know?
Well, we need to ensure that your communication efficiency is always above 70%. And we can do that with TALP.
Okay, so computer science department to the rescue. we have several tools for performance and malleability that can help you a lot with your simulations and prevent this murder.
What do you say? Malleability? What the hell is that? You always use some fancy words in computer science department. Looks too complicated. Anyway, I won't modify a line of code. I prefer to be killed.
Whoa, whoa. Let's start from the beginning. Can we see your code?
Yeah, this is the main. Don't touch it.
Okay, what do we have here? We have like a main loop over there.
It's not a main loop, it's a time loop.
Okay, a time loop. Some computation that I don't understand, some communication. Okay, here, I got it. We cannot align here calling DMR in order to reconfigure the application in the runtime. So it's just one line, not too bad, right? What do you think?
Okay, if it's one line, okay, so what's the plan?
Okay, the plan is, if TALP is measuring the efficiency of the application during its execution, DMR can reconfigure that application depending on that efficiency. So, in the case that you are not doing really good efficient execution, DMR will release part of those resources and reconfigure the application to run it with fewer MPI ranks.
And what? If it is good? I'm not always doing things bad, huh?
Well, if you are doing good, then you can keep going with your resources. But surprise, if you are doing too good, you even get more resources to your simulation.
Wow. Sounds good, but I don't get the whole picture.
Do you need a picture for that?
Yeah, I need a picture.
Okay, I have a picture. Don't run, anybody, so it's not a trace.
I know.
Okay, but first of that, there are two tricks.
Okay.
Yeah,
okay?
It's always tricky.
Yeah, that's tricky. It's not for free. So we need two things. One is a alarm policy. It's like a magic formula to estimate the number of MPIs to achieve that target efficiency. But don't worry about that because DMR provides it for you.
So what's the surprise?
The second one is that your code has to have an efficient data redistribution mechanism. Are you able to do that?
You have some doubt? Of course, ARIA runs fully parallel from the beginning until the end.
Okay.
Do you get it now or you still need a picture?
No, I need a picture now. Now the picture you can explain.
Okay, so let me show you the picture. In this picture, the blue line represents the communication efficiency measured by TALP. So in the x-axis, you have the different ALIA iterations and
okay, in the right y-axis, we have the number of MPI processes running on the allocated resources.
The gray area is the target communication efficiency that we want to achieve. So we see that your execution have a very good communication efficiency, above 90%.
Okay, in that case, DMR checks periodically, if every 1,000 iteration, that efficiency. If that efficiency is above the threshold, DMR gives you more resources and expands that job, increasing the number of MPI ranks and speeding up your application.
But at some point, you have too many resources, so then your communication efficiency drops.
Okay, in that case, it means that you are wasting resources. And we take those resources from your job and reduce the number of MPI ranks.
With that reduction, your communication efficiency gets better. We get in the target zone, and you can keep going with that number of resources. So now?
Okay, so if I understand well, I can run my simulation as fast as the code can, so very fast, without preoccupying about the resources. The sheriff will be happy, and I won't be killed.
Yeah.
That's it.
So this is a success story of why collaborating with application guys instead of killing them.
Yeah, having to trust them, which is not for free.
And leveraging Mare Nostrum resources to make the most of them.
Disclaimer, in this job, no animals were harmed, no Alia developers were harmed. Some jobs were killed.